Okay, so hello everyone. My name is Mattia Manzati. I'm a core contributor to Effect, and I'm also a founding engineer at Effectful Technologies. And as you can see, I really care about safety and recursion calls. So today I want to take you on a journey. Let's start by seeing a scenario that basically every one of us knows. So here has our order processing code that looks clean and typed. And TypeScript is basically giving us a green light saying, okay, there are no errors. So feeling confident, what we do is we start and we deploy to production, obviously on Friday afternoon, because that seems a very good idea. So then we go home, and Saturday morning, we receive a lot of calls because turns out that orders are start to fail and customers are angry. And your weekend basically is ruined. So what happened? What went wrong? Well, the worst part is that TypeScript couldn't tell us. All of those potential failures we had in our application were invisible to the type system. And they were basically lurking as runtime bombs in our seemingly perfect code. So let's unpack what's actually happening here behind the scene in that innocent looking code. So a simple database query, well, turns out that if the connection pool is exhausted, it can time out. Or a charge payment API call, well, maybe it gets rate limited with 100 requests per second. And it turns out that shipping API is not so stable and sometimes have some network hiccups. And every of these errors that I mentioned is now basically poisoning all of your call stack and contaminating all of your application. So what do? Well, we wrap everything in try, catch, block, and that's it, right? Problem solved. Well, not even close. Because that's the cruel joke, that TypeScript basically types your error in the catch block as unknown. And so that means that you have no idea of what you're catching. Is that a database connection error? Is that a network error or whatever? Who knows? So now you are basically playing detective and you are digging through the documentation, hope it exists, and reading the source code of your code, third-party libraries, whatever, finding all of the possible errors and then starting to add instance of checks, hoping that you have covered all the cases. Because again, if you missed just one, well, we are back to 2 a.m. phone calls. So I would say that this is not how we do error handling, it's more like error gambling, maybe. So the thing is that this gets even worse because errors don't stay contained. So what happens if one of your teammate calls that process order function maybe 6 months later? How do they know that that could fail with a connection error or a shipping rate limit error? Well, they don't. And so what happens is that they call our function, someone else called the function that they wrote, and someone else is again called that function. So we have basically an invisible net of potential errors through our entire code base. And this disease has a name, and it's called happy path blindness. Basically, we spend 90% of the time when we write code or when we write anything, crafting for the perfect success case, where everything goes right. And our code basically reads like a fairy tale where everything goes smooth. But we are just telling ourselves a comfortable lies because the database is always up, the service is always reachable, the payment will always go through. Well, they are lies. They are something that we are only telling ourselves. And reality is really different because in reality, everything can go wrong. So in reality, it's Murphy's law that rules. So there has to be a better way, right? So turns out that the problem is not TypeScript itself. TypeScript, again, is a great language. The problem is that that promise of an order is only telling us half of the story. It whispers about the success case of our computation, but what about the failure? It stays completely silent. So what if we could change that? So what if those red squiggles that catch our typos and type errors can possibly like refuse to compile until we have catched every possible error and deal with them? That's a world we want to live in, right? And well, good news, that's not a fantasy, it's a real-world pattern that's called error as values. And the key insight is that instead of throwing errors into the void, what we do is return them as part of our function result. And having them part of our function result means that now they are first-class citizens in our type system, exactly like the success case. And when that happens, that means that the compiler can track them. And so let's try to apply this pattern. We can really simply implement this in TypeScript by defining, for example, a result type that has a tag of success and a value of A, or a tag of failure and an error of E. So basically, that's a discriminated union by attack. And now when we have to implement our function, we need to, for example, if we have a defined function and the value of b is 0, we need to check if b is 0. And now instead of throwing, what we do is return the failure tag alongside our error. And if that's fine, we continue. And then finally, we return the success case with the value of I divided by b. And why do that? Well, look at now those beautiful squiggles. Now they are basically screaming at you because you forgot to check if the function succeeded or failed first, right? So this is the first beauty of that. But there is another mostly a more important part of that. If we look at the happy path of the success, yes, we get the correct type. But the most important part is that now the failure path is correctly typed. And this is exactly one of the core ideas that effect brings to TypeScript. An effect is basically a lazy evaluated computation which describes how our program can succeed, how they can fail, and what requirements they need in order to be executed. And other than that, effect also provides structured and controlled concurrency primitives that allow you to build a robust application. So let's start by rewriting the same develop function we had before with effect. So as we can see, it's very similar to before. We just use effect.fail to construct the failure case and effect.succeed to return the division of both numbers. But again, effect is a lazy computation. So if we try to look for a value or error property, they won't be there. They won't be there because, again, effect is lazy, so that means that effect hasn't executed yet. And to actually execute an effect, what we need to do is to hand the effect to the effect runtime by using some APIs like effect.runPromise or effect.runSync. And this basically hands your effect to the runtime. The runtime will interpret the effect and execute the actual work. And the first time, we can see that indeed our signature of the return type of divide now contemplates an error. And that's great, but, well, an error. Kind of generic. So that's why effect give us utility functions like effect.dataTaggedError. And that hub has create domain-specific error types. And yes, I know that this syntax at first sight can be something like from another language, but I assure you that this is 100% valid TypeScript. And basically, each error gets a string tag, like division by 0 or rate limit error, and that will allow us to discriminate that specific kind of error along a union of multiple kinds of errors. But the other interesting part is that now the errors are not just the signals. They are now a rich data structure that can contain also information about the error that happened. So that means that we can later on carry that information and use that to perform different error handling strategies. And now, let's focus on our type signature. Look at what happens. They are now self-documenting contracts. Let's try to read the signature of process order. It says that a process order takes in an order ID and returns an effect that may succeed with the shipping or fail with an order not found or payment failed. What I've just read, it's not a comment. That's not documentation that will go stale because, let's face it, no one wants to write documentation. That's the actual type signature, and it's telling us everything, every single thing that can go happy and that can go wrong. So what happens now when a new developer joins your team or tries to call your functions? Well, they just look at the type signature and they immediately see what can go wrong. Or what happens if you are an AI assistant and you are trying to figure out what errors can happen? Now you don't have to waste tokens trying to look at the functions implementation. You can just ask the LSP, give me the type signature, and you can infer what can go wrong from there. And that's what I mean by beautiful types, because now they are telling the complete story, not just the fairy tale happy ending that we had before. But we know that real applications aren't just a single divide function, right? They are usually a composition of many operations. And as we mentioned before, effects are lazy. So that means the traditional way of function calling won't cut it here. So that's why effect has two primary ways to compose effects. We have effect.gen, which can be used for imperative-like business logic, and we have .pipe that can be used to compose high-order transformations of your effect. And effect.gen is, in my opinion, one of the secret weapons of effect, because that's a generator syntax that looks almost identical to async await. And everyone is familiar with async await, right? Basically, instead of await, you use yield star, and instead of a sync function, you write effect.gen function star. And that's it. The rest looks like the imperative code you've always been writing. That's linear, that's sequential, and that's readable. But here's the kicker. Why using generator? Well, this familiar looking syntax, it's also fully type safe. Because every time you yield star an effect, what happens behind the scene is that TypeScript will automatically infer the list of possible error of the resulting effect based on what you yielded. So you don't have to manually write that union of errors. And again, the other way to compose effect is by using pipe, as the name suggests. It works exactly like a pipeline. And with pipe, you can basically apply additional transformations to previously defined effect. Basically, whatever function takes in effect, change the behavior of effect, and returns a new effect. You can, for example, append new execution of effects to be run, or append error running logic, or whatever. Traditional function calling would have worked for that as well, but you know, having pipe moves the way you read the composition, because instead of reading like from the innermost function to the outermost function, with pipe instead you read from left to right, which is usually what we are used to. And sure, accumulating errors is great, but not useful at all, because eventually we need to handle them. And that's where the specific error types we have defined before comes really handy. Because thanks to the type union of errors, now we can easily define which kind of errors we want to handle and provide, for example, a fallback logic for a specific kind of error that may happen. For example, a user not found error. And as I always told to my grandma, when the TV doesn't work, plug it off, plug it on again, and it works, right? And so the same goes for some kind of errors, right? You just retry and they go away. Things like temporary connection errors, database connection error, whatever. And effect being lazy means that they have these by default. Retries are a primitive that's built in by effect. And with a couple lines of code, you can create complex retry logic. For example, define, okay, I want an exponential retry that happens only when a network error happens, right? That would be a madness to write in plain JavaScript, but with effect, it's built in. So you just say, okay, I want to retry, and effect will do that for you. But there are some cases that even if we say that we have a retry policy, let's say, of 10 times, we get to the 11 and we still fail. And we didn't expect to reach that point. Or what happened if we have, for example, an error that we didn't account for? Well, that's why effect has an additional error channel that's not shown in the type parameters, and hence why it's not shown is because it's typed as unknown. And basically in the effect channel that goes any kind of error we don't expect any possible recovery from. As I said before, unexpected errors or retries failing. And given these two kinds of potential errors, you can imagine that's not so uncommon in effect that you start by defining an effect function and have locally typed and expected failures, and then at some boundary of the application, maybe you reach a boundary where you say, okay, I try to handle that error, I apply some retries, and then you get to another boundary as well and say, okay, I have expected that those errors should have been gone. And if they are not, you can use some combinators, like, for example, effect or die, that basically converts your typed failures into a defect. So basically you perform a cleanup of the error channel. You can see that after using or die, now our typed error channel goes back to never. But we have spoken enough about success and failure. So what's that third type parameter? Well, the requirements. Effect has a built-in dependency injection system, and it's type safe. And the first thing that we need to use it is to define a tag, which is basically an identifier that represents our actual service implementation, and alongside the shape of our service. And to do that, we can use the context.tag API, which is very similar to the one that we have seen before, and that will allow us to get for free three things, because we will get basically an opaque type identifier that will appear as a third type parameter. We will get also like the shape of the service, like methods we expect to have. And finally, we will also have some runtime value. We will have the class definition as a runtime value to identify that dependency. And now that we have defined the service, we need to access it. How? Well, in effect, if we are, for example, inside an effect.gen, we can just yield things. You can just yield the tag identifier of your service, and you will get back the actual implementation. And then with the actual implementation, you can call the methods you have on your effect. And again, you can see that the generators are smart, because when we yield service, we automatically get to the resulting inferred effect as third type parameter the service that we yielded. And now what happens if we try to run that promise of run to that effect by using, for example, effect.runPromise? Well, we will get a type error. Why? Well, we have defined the service, we have used it, but we need to implement it now. And to do so, you can use some APIs, like, for example, effect.provideService, which will basically require us to provide, again, the identifier tag that we have defined before, and alongside, we need to provide also like the implementation. And the implementation will be type checked against the tag that we have defined before. And now you can see that we can safely call again our effect.runPromise, and we will get no error, because again, when we provide the implementation by using effect.provideService, you can see now that indeed that third type parameter gets away. And a dependency injection that's easy and type safe as the one that I provided by Effect makes it a breeze to mock dependencies in testing. Because now providing a mock dependencies does not require any magic of hooking into globals, injecting booleans to say I'm in testing or whatever. Because now testing effect code is just a meaning of providing a different implementation. So you can swap just that provide service that we have seen before, for example, and we will get a different implementation of the service in a single test or in our live environment. And also, as I have described before, this flow is really nice because we can now get this flow where first we define the shape of the service, we use it, and finally we implement it. So the shape of the service we define won't be tied to the actual service implementation, because that's the last thing that we will do. And we know that by default, every non-trivial application has a complex tree of dependency that are required to be constructed in order for the application to be executed. And that's why Effect comes with another primitive data type for this job that's called layer. And the layer basically represents an effectful constructor for a set of services that can be composed in the same way we have seen with Effect. And a layer has three type parameters. The first one is the set of services that the layer can construct. For example, let's say that we have a layer that constructs a connection. And the second one is the list of errors that may happen while constructing that service. For example, a connection error may happen while trying to construct a connection. And the last one is a list of additional requirements that are needed in order to construct the connection. For example, we may need, for example, to read from the file system a configuration. So we may have, for example, a configuration service or whatever. But now I want to ask you something. Now think about your production application. you indeed have some APIs, and probably you are querying some database or some external API as well, right? So now what happens in your application if I invoke your API and then I immediately quit the HTTP request? Okay, now I only see two possible reactions to that. The first thing is that, okay, I completely forgot about that. And right now, your application is basically suffering from user aborting requests. Because again, the request handler may be kept executing on the server, and you are basically wasting resources, because even if you keep executing the request, then the response won't get served. And you are, for example, wasting connection to your database pool. Or maybe you're saying, no, I don't care about that because my infrastructure automatically kills the JES execution upon the request abort. Well, bad news for you, because that also means that you are not properly disposing of the connection from the pool, for example. And that means that it will take more time for the connection to be restituted to the pool. So that's, again, not performant as well. And the other reaction you may have if you have not think, okay, I forgot about that, is, well, I have written a lint rule that says, okay, every function should take in an abort controller and I should handle the abort controller. And now your team is basically hating you because you introduced that rule, and that's awful. And well, but that means that even if you have that abort controller, that means if you have situations like racing different computations, now that means that you need to manually handle the composition of the abort signal. And I assure you that's not a trivial task. And another thing that changes that is that with Effect, the interruption is a built-in. So instead of passing down the abort signal from the top, basically you provide the interruption behavior at the most signal and small building block you may have in your application. For example, let's say that you do an HTTP request and you provide back the abort signal that Effect gives you for that. And now whenever you invoke that function, you don't need to change anything. Because again, the Effect runtime will automatically provide down the interruption signal starting from where you started your application. And Effect also gives you other ways to properly handle, for example, concurrency control. You can, for example, specify a max amount of concurrent execution of an effect, and Effect will automatically ensure that's met. But not also that. The other thing is that Effect will also build the proper interruption patterns to do so that outside interruption will propagate correctly. Also things like what happens if one of those batches of 3 effects fails, you need to interrupt the other one that are running without executing the next one in the queue. So again, that's not something trivial. I really challenge you to do that without Effect, and probably you'll see how hard is that. And well, what about the dev tools? Well, in the end, Effect really loves them because we have a lot of dev tools about Effect, but one of the things that I really love about Effect is that Effect has built-in telemetry instrumentation. So we know how hard it is to build a fully instrumented tracing in a distributed system, maybe front-end, back-end, or even different backends. But the story with Effect is completely different because Effect has built-in support for telemetry. So you just need to provide the name of the span. You may additionally provide other information to annotate the current span. And then at the edge of your program, what you need is to provide the exporter to your telemetry endpoint. And well, that's really it. Now you have full instrumentation to your code. And again, try to do that without Effect, and you'll see that's not a trivial task. And finally, just to recap, I also want to show you some things about other instrumentation that you can have inside your editor, because Effect has a language service plugin, and that means that Effect can provide additional experience in your editor to help you code better Effect code, but also to be more performant with it. For example, we know that the TypeScript type checker with this red squiggle has been a crucial error in the effect journey because, as we have seen before, it helps catching potential error of missing dependencies or whatever. But unfortunately, the errors of TypeScript are not great because TypeScript is a structural system, so usually they are not so readable. But the effect LSP fixes that by providing more readable errors for that. You can see, for example, in here that after I enable the language service plugin, I see something like missing the inventory service, which is like immediate and goes strictly to the point. And another point is that that can also be a great teaching tool because given all the type information that are encoding into the effect type, we can, for example, detect when a service is leaking the implementation detail of how it's built and suggest the user to remove that dependency in favor of providing that at construction site of the service. So again, thanks to the type, we can infer and help you a lot. Or we can, for example, do really simple things like, for example, when you yield star some effect inside your generator, you can hover that and see cleanly which are the requirements of your application, of your effect computation, the errors or whatever, in a complete way, regardless of how error truncation is set in your code base. But there are also things like custom refactor. So if you are thinking about adopting effects, you may be happy because the LSP, for example, have refactors that allows you to transform any async await function into an effect. And it already stubs out for you the errors. So you can just say, okay, rewrite that to effect, then you get some errors with some bogus name, you will give them more meaningful names, and you get effect code. And for the schema lovers, there is also like another interesting refactor that you can, for example, convert interfaces into schemas. And for those of you who doesn't know, schema is basically a library that by describing the structures of by describing the structure you have, you will get automatically things like parsing, encoding, or like JSON schema or whatever, and it's all based on describing the structure and then having interpreters on top of that. And also, as I mentioned initially, we know that every application by default have a non-trivial dependency tree. And non-trivial dependency tree are non-trivial to understand. And that's why the LSP also helps you try to understand why dependencies got involved and where they get provided or required. But again, if you are not like too much into textual things, you can also hover your layer, click Show Full Layer Graph, and you'll see a visual representation of the dependencies of your application. And that will help you try to understand by starting from the top and going down to understand where something is required or where it's provided. We have also another part of the tooling, which is a VS Code extension. And the purpose of that VS Code extension is to provide a better DX while debugging effect applications. Effect basically shares the same behavior of other technologies that have a description that's then run by a runtime, like for example React, where basically if you look at the traditional code stack, that's mostly polluted by internal runtime code. And so that's not so useful. But we have telemetry built-in spans. So we can provide a span stack that will basically try to fill that gap and see, okay, these are how I reach that point of execution in my code, and then you can hover, click, and jump to definition of that. And again, we love things that are visual, so what's better than something textual? Well, we have also like a real-time graph that has you step the bug, the updates, and shows you the span that are running in your application. So you can see what's running on your application. Well, with all of that I've talked today, I hope that I have inspired you to use Effect if you are not using it yet. So, well, does that mean that now you have to go home and tonight drop your entire code base and start writing Effect code? Yes, no, sorry, that's not what I would recommend you. But, well, Effect, as we have seen in the slide, have functions like effect.runPromise that allows you to convert an effect into a promise, so that can interrupt, for example, with your existing code base, but also you have functions that do the opposite. Starting from a promise, you can convert that into an effect and provide typings for the possible errors. So that means that you can start replacing promises and async await code gradually in your application, starting maybe by the most crucial part or sensitive parts of your application. And then from there, start evolving and adopt fully Effect. So with that, thank you very much for listening to me. It's been a pleasure. Now go home and start using Effect.